The universe is vast, mysterious, and filled with objects so strange, they seem to defy everything we thought we knew about physics. From stars that shouldn't exist, to planets made of diamond, from cosmic zombies that refuse to die, to objects so dense they warp the very fabric of space and time, the cosmos has a way of surprising us at every turn. Before we dive into today's mind-bending journey through the cosmos, make sure to hit that subscribe button and ring the notification bell. Trust me, you won't want to miss what we're about to show you. Today, we're taking you on a tour of the most bizarre, mind-boggling discoveries that have left astronomers scratching their heads and rewriting textbooks. These aren't just distant lights in the sky. They're cosmic enigmas that challenge our understanding of reality itself. Some of these objects are so weird, they sound more like science fiction than science fact. So buckle up as we explore the strange side of space, where the impossible becomes possible and the universe reveals its most closely guarded secrets. You're about to discover that truth really is stranger than fiction, especially when it comes to the bizarre objects lurking in the depths of space.
What if I told you that somewhere in our universe, there's a star made entirely of diamonds? Or that there are objects so dense that a teaspoon of their material would weigh as much as Mount Everest? Welcome to the Cosmic Freak Show, where reality is stranger than any science fiction you've ever imagined. I'm your host, and today we're going on a journey through space to discover the most bizarre, mind-bending, and downright impossible objects that actually exist in our universe. From stars that shouldn't be possible to planets raining glass sideways, buckle up, because we're about to explore phenomena that will make you question everything you thought you knew about reality. Let's dive into the strangest objects in our universe. Neutron stars, the universe's densest objects. Imagine crushing our entire sun down to the size of Manhattan. That's essentially what a neutron star is. And it's just the beginning of how weird these objects get. Neutron stars form when massive stars explode in supernovas. The core collapse is so violent that protons and electrons are literally crushed together to form neutrons. The result? An object so dense that a sugar cube-sized piece would weigh 6 billion tons. That's heavier than all of humanity combined. But here's where it gets truly bizarre. Neutron stars spin. And when I say spin, I mean they rotate up to 700 times per second. That's faster than a kitchen blender. Some neutron stars, called pulsars, emit beams of radiation from their magnetic poles. As they spin, these beams sweep across space like cosmic lighthouses, and we can detect these pulses here on Earth. The magnetic field of a neutron star is 1 trillion times stronger than Earth's. If you had a neutron star the size of a city anywhere in our solar system, it would strip the magnetic data from every credit card on Earth, get within 600 miles of one, and the magnetic field would literally rearrange the atoms in your body. The surface of a neutron star is equally mind-boggling. It's essentially one giant atomic nucleus, the largest atom in the universe. Mountains on neutron stars are only millimeters tall because gravity is so intense. And if you somehow manage to drop something from just 1 meter above the surface, it would hit the ground at 7 million kilometers per hour. But perhaps the strangest thing about neutron stars, they ring like bells when disturbed, creating starquakes that release more energy in milliseconds than our sun produces in 20 years. Black holes, where physics breaks down. Black holes are the universe's ultimate mystery. Regions of space-time where gravity is so strong that nothing, not even light, can escape. But the reality of black holes is far stranger than most people realize. First, let's talk about time dilation. As you approach a black hole, time literally slows down relative to the outside universe. If you were watching a friend fall into a black hole, you'd see them slow down, redshift, and eventually appear to freeze at the event horizon, even though from their perspective, they'd fall in normally. But here's what's truly weird. According to our current understanding of physics, if you fell into a black hole, you'd experience something called spaghettification. The gravitational difference between your head and feet would stretch you into a long, thin shape, like a piece of spaghetti. Not exactly a pleasant way to go. At the center of every black hole lies the singularity, a point of infinite density where the laws of physics as we know them completely break down. It's smaller than an atom, but contains the mass of entire stars. What happens at a singularity? We honestly don't know. Our mathematics simply can't describe it. Recent discoveries have revealed that black holes aren't actually black. They emit something called Hawking radiation and slowly evaporate over time. Paradoxically, smaller black holes evaporate faster than larger ones. A black hole with the mass of our sun would take longer than the age of the universe to evaporate. But a black hole, the mass of a mountain, would explode with the energy of 1,000,000 hydrogen bombs. And here's something that will blow your mind. Some scientists theorize that our entire universe might be inside a black hole. The Big Bang might actually be what falling into a black hole looks like from the inside. Magnetars, the universe's most powerful magnets. If neutron stars are weird, magnetars are their psychotic cousins. These are neutron stars with magnetic fields so powerful they redefine what we thought was possible. A magnetar's magnetic field is 100 million times stronger than any magnetic field we can create on Earth, and a quadrillion times stronger than our planet's magnetic field. To put this in perspective, a magnetar, located halfway between Earth and the Moon, would strip all the magnetic data from every credit card on our planet. But it gets stranger. The magnetic field of a magnetar is so intense that it warps the very atoms around it. Atoms become stretched into thin cigars, completely changing how chemistry works. If you were within 600 miles of a magnetar, the magnetic field would interfere with your nervous system's electrical impulses. You'd literally lose consciousness before the radiation killed you. Magnetars occasionally have what astronomers call starquakes, cracks in their ultra-hard crusts. When this happens, they release more energy in 1/10 of a second than our sun produces in 100 years. In 2004, a magnetar 50 light-years away had such a starquake that it temporarily blinded satellites in our solar system and affected Earth's magnetic field. The most terrifying part? These starquakes can literally tear apart the fabric of space-time itself, creating gravitational waves that ripple across the universe. Magnetars are so extreme that they're essentially testing the limits of what matter and energy can do in our universe. The diamond planet FT5 Cancri E, located 40 light-years from Earth, is a planet that sounds like something from a fairy tale. 55 Cancri E, a world made largely of diamond. This super-Earth is about twice the size of our planet, but 8 times more massive. What makes it truly bizarre is its composition. The planet formed in a carbon-rich environment, and under the extreme pressure and temperature conditions, much of its interior crystallized into diamond. We're not talking about small diamonds here. This planet contains more diamond than exists in Earth's entire crust. If you could somehow mine this planet, you'd crash the diamond market permanently. The planet is worth about $26.9 million. That's 384 quadrillion times more than Earth's entire GDP. But 55 Cancri E isn't just valuable, it's hellish. The planet orbits so close to its star that a year there lasts only 18 Earth hours. The dayside temperature reaches 400 degrees Celsius, hot enough to melt copper. The nightside, meanwhile, is a relatively cool one, 100 degrees. What's particularly strange is that this diamond world has an atmosphere. Despite the extreme conditions, it maintains a thin atmosphere of hydrogen and helium. Scientists think it might even have weather, but instead of water clouds, it would have clouds of vaporized rock. Imagine standing on a world where the ground beneath your feet is literally made of the most precious substance on Earth, while above you it's raining molten rock under a sky glowing with the heat of a nearby star. Rogue planets. The cosmic wanderers. Not all planets orbit stars. Scattered throughout our galaxy are billions of rogue planets, worlds that have been ejected from their solar systems and now drift alone through the cold darkness of space. These cosmic orphans are more common than we ever imagined. Recent estimates suggest there might be more rogue planets in our galaxy than there are stars. Think about that. For every sun you see in the night sky, there could be multiple planets wandering, unseen in the void between stars. Some of these rogue planets are truly bizarre. Without a sun to warm them, their surfaces are frozen wastelands, with temperatures near absolute zero. But some might have thick atmospheres that trap geothermal heat from their cores, creating pockets of liquid water beneath ice-covered surfaces. One of the strangest rogue planets discovered is called CFBD-SIR 2149-403. This world is roughly the size of Jupiter, but completely alone, floating through space about 100 light-years from Earth. It's been wandering for millions of years, and it glows with a dim infrared light from its own heat. But here's what's truly mind-bending. Some rogue planets might support life. Deep beneath their frozen surfaces, geothermal vents could provide energy for ecosystems completely independent of any star. These would be biospheres that exist in permanent darkness, sustained entirely by their planet's internal heat. There might even be rogue planets with moons. Imagine a world system drifting through space, a planet with its own satellites, creating tides and geological activity, all happening in the eternal night between stars. It's like a pocket of planetary activity completely disconnected from any solar system. Quasars. When black holes go wild. Quasars are what happens when supermassive black holes go absolutely berserk. These are the brightest objects in the universe, shining with the light of trillions of stars while being smaller than our solar system. At the heart of every quasar is a supermassive black hole that's actively feeding. As matter spirals into the black hole, it forms what's called an accretion disk. The friction and magnetic forces in this disk heat the material to millions of degrees, causing it to shine brighter than entire galaxies. But the truly strange part isn't the light, it's the jets. Quasars shoot out beams of particles at nearly the speed of light, extending for millions of light years. These jets are so powerful, they can affect the formation of stars in galaxies billions of light years away. They're literally reshaping the structure of the universe. The energy output of a quasar is almost incomprehensible. A typical quasar produces 100 times more energy than our entire Milky Way galaxy. If you replaced our sun with a quasar, it would appear as bright as the sun does from Earth, even from a distance of 33 light-years. What's particularly weird is that we mostly see quasars from the early universe. They were much more common billions of years ago, when galaxies were younger and had more gas to feed their central black holes. In a sense, looking at quasars is like looking at the universe's wild adolescence, a time when galaxy formation was chaotic and violent. Some quasars change brightness dramatically over just days or weeks. Since light can only travel so fast, this tells us that the energy-producing region is incredibly compact, smaller than our solar system, but producing more energy than a trillion stars. Dark matter structures, SEN, the invisible universe. Perhaps the strangest objects in our universe are ones we can't even see. Dark matter structures. Dark matter makes up about 85% of all matter in the universe. Yet it doesn't interact with light or ordinary matter in any way we can detect. We know dark matter exists because we can see its gravitational effects. Galaxies rotate too fast to be held together by just the matter we can see. Galaxy clusters move in ways that only make sense if there's much more matter than we observe. The cosmic web, the large-scale structure of the universe, is shaped by dark matter. But what is dark matter? We don't know. It could be particles that barely interact with anything. It could be primordial black holes. It could be something we haven't even theorized yet. What we do know is that dark matter forms its own structures, vast halos around galaxies, filaments stretching across space, and dense clumps that we can map by their gravitational effects. Here's what's truly strange. There might be entire dark matter galaxies out there, structures made entirely of dark matter with no ordinary matter at all. These dark galaxies would be completely invisible, but could be as large as the Milky Way. Some scientists theorize that dark matter might form its own complex structures, dark matter planets, or even dark matter life. If dark matter particles can interact with each other in ways we don't understand, there could be an entire shadow universe of dark matter objects existing alongside our own. Recent simulations suggest that the smallest dark matter structures might be incredibly dense. Dark matter clumps the size of Earth, but with the mass of the Sun scattered throughout our galaxy. If one passed near our solar system, we'd detect it only through tiny changes in planetary orbits. The Boötes Void, the Great Nothing. In the constellation Boötes lies one of the most unsettling objects in our universe, a region of space so empty that it's been nicknamed the Great Nothing. The Boötes Void is a roughly spherical region of space, about 330 million light-years in diameter, that contains almost no galaxies. To understand how strange this is, consider that in a typical region of space this size, you'd expect to find about 20 galaxies. The Boötes Void contains only about 60. It's like finding a major metropolitan area with only a few dozen houses scattered across it. What makes the void even more mysterious is that we don't know how it formed. Computer simulations of the universe's evolution can't easily explain how such a large empty region could develop. The void is so large that light takes 330 million years to cross it. It's one of the largest known structures in the universe, defined entirely by what's not there. From the perspective of any hypothetical aliens living in one of the few galaxies inside the void, the night sky would be nearly empty. They might not even know that other galaxies exist. Their entire observable universe would contain only a handful of other galaxies, making them cosmically lonely beyond our comprehension. Some scientists have proposed that voids like this one might be where dark energy, the mysterious force accelerating the universe's expansion, is strongest. The void might be expanding faster than the rest of space, stretching what few galaxies exist there further and further apart. Standing at the edge of the Boötes Void and looking in would be like staring into the abyss of space itself. A reminder that our universe is not just full of strange objects, but also strange absences. Strange stars and impossible objects. Our universe is full of stars that shouldn't exist according to our understanding of stellar physics. Yet there they are, challenging everything we thought we knew. Take Przybylski's star, located about 370 light-years from Earth. This star contains elements that shouldn't exist in nature, including short-lived radioactive elements like actinium and holmium. These elements decay so quickly that they shouldn't be found in any star. Either this star has some unknown nuclear process creating these elements, or it's somehow incorporating material that was created very recently on a cosmic timescale. Then there's the Methuselah star, officially known as HD 140,283. This star appears to be older than the universe itself, about 14.5 billion years old, while our universe is only 13.8 billion years old. It's like finding a person who claims to be older than human civilization. Scientists are still trying to resolve this paradox. Wolf-Rayet stars are perhaps the most violent stars in the universe. These massive stars have shed their outer hydrogen layers, revealing cores that burn at temperatures of 50 degrees Celsius. They blast stellar wind into space at speeds of up to 30 kilometers per second. Some Wolf-Rayet stars lose the equivalent of Earth's mass every year just from their stellar wind. But perhaps the strangest stellar object is the Thorn-Zhitkau object, a theoretical star within a star. These bizarre objects would form when a neutron star gets swallowed by a red giant star. The result would be a star with the neutron star as its core, creating nuclear processes that simply don't exist anywhere else in the universe. In 2014, astronomers think they may have found the first Thorn-Jitkow object, a star called HV 2112, in the Small Magellanic Cloud. If confirmed, it would be one of the most exotic objects ever discovered, a star powered by physics we're only beginning to understand. Time dilation objects and gravitational anomalies. Some of the strangest objects in our universe aren't just weird because of what they're made of, but because of how they affect the very fabric of space-time itself. Frame-dragging effects around rotating massive objects create regions where space and time are literally twisted. Around rotating black holes, there's a region called the ergosphere, where it's impossible to remain stationary relative to distant stars. Space itself is being dragged around by the black hole's rotation. Gravitational time dilation means that time passes differently depending on how strong the gravitational field is around you. On the surface of a white dwarf star, time runs about 50 seconds slower for every minute compared to Earth. On a neutron star, this effect is so extreme that time crawls at just a fraction of the normal rate. But perhaps the strangest temporal object is a closed time-like curve, a theoretical path through space-time that leads back to its own past. While we haven't found any confirmed closed time-like curves, some solutions to Einstein's equations suggest they might be possible around certain exotic objects. Wormholes, if they exist, would be shortcuts through spacetime connecting distant regions of the universe. Traversable wormholes would require exotic matter with negative energy density, something we've never observed but can't rule out entirely. The strangest part about these objects is that they remind us that space and time aren't the fixed stage we imagine them to be. They're dynamic, flexible, and can be warped, twisted, and stretched by matter and energy in ways that still boggle our minds. Conclusion: the universe's greatest mystery. From diamond planets to time-dilating stars, from invisible dark matter to voids of nothingness, our universe is far stranger than we ever imagined. These objects challenge our understanding of physics, chemistry, and reality itself. But perhaps the strangest thing of all is that we exist to observe them. In a universe filled with neutron stars, black holes, and cosmic voids, somehow matter organized itself in just the right way to create beings capable of wonder, curiosity, and the drive to understand. Earth appears as a tiny marble, suspended in the void, fragile, precious, and utterly unique. But is it really? For centuries, humans gazed up at the night sky and wondered, are we alone? Do other worlds exist beyond our solar system? The ancient Greeks speculated about it. Galileo pointed his telescope toward the stars, hoping to find answers. But it wasn't until 1995 that we got our first confirmed glimpse of an alien world. The planet was called 51 Eridani, B, a gas giant, orbiting a star 51 light-years away. It was nothing like Earth, but it was something magnificent. Proof that our solar system wasn't the only game in town. Since then, we've discovered over 50 exoplanets, each one telling a different story about how worlds can form and evolve. Now, imagine if we could actually visit these distant realms. What would we see? What would we feel? What wonders await us in the cosmic deep? Our journey begins as we accelerate past the speed of light, leaving behind the familiar planets of our solar system. Mars shrinks to a red pinprick. Jupiter's great red spot becomes just a memory. Soon, even the sun itself fades to just another star among billions. We're entering interstellar space now, that vast emptiness between star systems. But even here, in what seems like perfect void, there are surprises. Rogue planets' worlds, ejected from their home systems, drift in eternal darkness. Some of these cosmic wanderers might harbor life, warming themselves through radioactive decay or tidal heating, creating hidden oceans beneath frozen surfaces. But our destination lies ahead. Star systems where alien suns cast their light on worlds beyond imagination. The hellish worlds. Our first stop, HD 189,733b, a planet that redefines the meaning of hostile environment. From a distance, this world appears deceptively beautiful, a brilliant blue marble that might remind you of Earth. But don't let that azure glow fool you. As we descend through its atmosphere, the truth becomes terrifyingly clear. This isn't water blue we're seeing. It's the result of silicate particles suspended in the air. The temperature here reaches 800 degrees Fahrenheit, hot enough to melt copper. But temperature is the least of our worries. The winds on HD 189,733b blow at over 500 miles per hour. That's nearly 6 times the speed of sound. And those silicate particles I mentioned, they're actually microscopic glass shards, creating storms of molten glass that scream across the planet's surface at hypersonic speeds. Imagine standing on this world if you could survive for even a split second. Above you, clouds of vaporized rock dance in the alien sky. The air itself is a weapon. Each breath would be like inhaling liquid fire mixed with ground glass. This is a planet where the very atmosphere wants to kill you. Yet there's a terrible beauty here. At the boundary between day and night, the Terminator line, we witness one of the most spectacular sights in the known universe. Here, in the perpetual twilight, metallic snow begins to fall. Not water snow, but tiny droplets of vaporized iron and other metals, condensing in the slightly cooler temperatures and drifting down like deadly confetti. But HD 189,733b isn't alone in its hostility. Let's visit another world where the very rain is made of metal. On WASP 76b, the dayside temperatures soar to over 40 degrees Fahrenheit. Here, iron doesn't just melt, it vaporizes completely, rising up into the atmosphere as metallic clouds. As we move to the night side of this tidally locked world, something magical and terrifying happens. The iron vapor cools and condenses, creating droplets of liquid metal that fall from the sky like a deadly precipitation. It literally rains liquid iron on WASP 76b. Standing on the night side of this world, you would witness an iron rainstorm, each droplet glowing red hot as it falls through the thick atmosphere, creating streams of molten metal that flow like lava rivers across the planet's surface. These hellish worlds remind us that the universe doesn't play by Earth's rules. They're laboratories of extreme physics, showing us what happens when planets form too close to their stars, where the fundamental forces of nature create environments so alien that they stretch the limits of our imagination. The ocean worlds. Now, let's journey to calmer waters quite literally. Our next destination, Gliese 1214b, a world that might be the closest thing to a true ocean planet that we've discovered. As we approach this super-Earth, located 40 light-years from home, we're struck by its alien beauty. The entire planet appears to be covered by a global ocean, deeper than anything on Earth. But this isn't an ocean of familiar H2O in its liquid form. This is something far more exotic. The pressure at the surface is so immense that water exists in a state unknown on Earth, a hot ice called Ice the Seven. Imagine diving into an ocean where the water is simultaneously liquid and solid, where the rules of physics create forms of matter that seem to defy common sense. But the real magic happens as we descend deeper into this alien ocean. The pressure increases exponentially, creating layers of different exotic ices. First Ice 7, then Ice X, and deeper still, forms of ice that only exist in the most extreme conditions in the universe. At the very bottom of this ocean, compressed by the weight of hundreds of miles of water above, we might find Ice 8, a form of ice so dense and strange that it exists nowhere else in our solar system. Yet life, as we've learned, has a way of surprising us. In the middle depths of this ocean world, where temperatures stabilize and pressure creates a perfect balance, there might be layers where liquid water, true liquid water, exists in vast, planet-spanning seas. Picture swimming through these alien waters. Above you, miles of exotic ice. Below, more miles of even stranger ice formations. But here, in this magical middle zone, liquid oceans that dwarf all of Earth's seas combined. What creatures might call such a place home? Our journey continues to an even more intriguing ocean world, Ka-218b. This super-Earth, discovered in its star's habitable zone, has captured the imagination of scientists worldwide. Recent observations have detected something remarkable in its atmosphere: water vapor. But Ka-218b holds an even more tantalizing secret. Beneath its hydrogen-rich atmosphere might lie global oceans of liquid water, protected from space by a blanket of gas thick enough to maintain stable temperatures across the entire planet. Standing on a floating platform in Ka-218b's oceans, you would see a sky unlike anything on Earth. The atmosphere, rich in hydrogen and helium, would create optical effects that paint the heavens in impossible colors. Sunsets would last for hours as light bends and refracts through layers of alien gases. The oceans themselves might be warm and inviting, heated by geothermal vents and the planet's own internal warmth. Imagine diving into these waters, where bioluminescent organisms, if they exist, might create light shows that put Earth's aurora borealis to shame. But perhaps the most exciting possibility is what we might find in these alien seas. On Earth, every drop of water harbors life. Could the vast oceans of these distant worlds be teeming with alien organisms, evolved over billions of years in environments we can barely imagine? The search for life in these cosmic oceans has become one of the most exciting frontiers in modern astronomy. Each new discovery brings us closer to answering that fundamental question: are we alone? The Diamond Worlds, our cosmic voyage, now takes us to worlds that literally sparkle with unimaginable wealth. Welcome to the Diamond Planet's worlds, where carbon has crystallized on a scale that defies comprehension. Our first stop, 55 Cancri E, a planet so rich in carbon that its surface is likely covered in diamond formations kilometers thick. As we approach this super-Earth, the light from its parent star refracts through a landscape made of pure crystal, creating rainbow prisms that dance across the horizon. Walk across the surface of 55 Cancri E, and you would literally be walking on diamonds. Not small gems, but massive crystalline formations, diamond mountains that rise toward alien skies, diamond plains that stretch beyond every horizon, diamond caves that burrow deep into the planet's interior. The temperature here reaches over 3,900 degrees Fahrenheit, hot enough to melt gold, but not hot enough to destroy the diamond formations that give this world its incredible character. Instead, the extreme heat creates something even more spectacular: diamond rain. In the upper atmosphere of 55 Cancri E, carbon vapor condenses under the intense pressure, forming tiny diamond crystals that fall like the most precious snow in the universe. Each snowflake is actually a microscopic diamond, and they fall by the billions, constantly resurfacing the planet with layers of crystalline wealth. But the true spectacle happens during the planet's day-night cycle. The best, 55 Cancri E, is tidally locked to its star, meaning one side faces eternal day while the other experiences perpetual night. At the terminator line, the boundary between these two worlds, something magical occurs. The temperature differential creates massive storms of diamond dust that sweep across the landscape like glittering tornadoes. These storms, visible from space as shimmering spirals of light, redistribute the planet's crystalline surface in patterns that change over time, making this world a constantly evolving work of cosmic art. Now imagine standing on the night side of this diamond world. The surface, cooled by the absence of starlight, would be covered in formations of pure crystal that stretch in every direction. Above you, the alien stars would shine through a thin atmosphere, their light catching and refracting through the diamond landscape, creating a natural light show that turns the entire surface into a cosmic disco ball. But 55 Cancri A isn't the only diamond world in our galaxy. Deep space observations have revealed other carbon-rich planets where similar processes might be occurring. On some of these worlds, the diamond formations might be even more extreme. Picture a planet where diamond formations have grown for billions of years, creating crystalline structures the size of continents. Imagine diamond canyons carved by ancient rivers of liquid carbon, diamond spires that rise hundreds of miles into the atmosphere, diamond caves that honeycomb entire regions of the planet's crust. These diamond worlds challenge our understanding of planetary formation and evolution. They show us that the universe is capable of creating beauty on scales we never imagined. Worlds where the most precious substances on Earth are as common as sand on a beach. Yet perhaps the most incredible thing about these diamond planets isn't their wealth. It's what they tell us about the diversity of worlds in our galaxy. If planets can be made of diamond, what other impossible worlds might be waiting for us to discover? The frozen realms. Our journey now takes us to the frozen frontiers of space, where alien worlds exist in states of perpetual winter that make Antarctica look tropical. But don't mistake these ice worlds for lifeless wastelands. They harbor some of the most intriguing possibilities for alien life in the universe. Welcome to TRAPPIST-1e, a world locked in eternal winter, orbiting a red dwarf star in a system that has captured the imagination of astronomers worldwide. As we descend through its thin atmosphere, we see a landscape that seems familiar, yet utterly alien. Vast ice sheets that stretch beyond every horizon, but composed not just of water ice, but frozen carbon dioxide, methane, and exotic compounds that exist nowhere on Earth. The surface temperature here hovers around -80 degrees Fahrenheit, cold enough to freeze the air you breathe. Yet beneath this frozen exterior lies one of the most exciting discoveries in modern astronomy: the potential for liquid water oceans hidden beneath kilometers of ice. Using our advanced sensors, we penetrate the ice sheet and discover something remarkable. Deep below the surface, heated by tidal forces and the planet's own radioactive core, vast liquid oceans slosh in eternal darkness. These subsurface seas might contain more water than all of Earth's oceans combined. Imagine descending through the ice of TRAPPIST-1e, through layers of frozen gases and exotic ice formations, until you break through into the liquid realm below. Here, in the eternal night of this alien ocean, hydrothermal vents might spew mineral-rich water into the sea, creating oases of warmth in the cosmic deep. But TRAPPIST-1e has an even more intriguing secret. This frozen world experiences something no planet in our solar system does: synchronized orbital resonances with its neighboring planets. As these worlds dance their gravitational ballet, they flex and stretch TRAPPIST-1e's interior, generating heat that might keep those subsurface oceans liquid for billions of years. Our voyage continues to an even more extreme frozen realm, Proxima Centauri b, the closest confirmed exoplanet to Earth, just 4.2 light-years away. This world, tidally locked to its red dwarf star, presents us with a planet of two faces. On the day side, temperatures might be warm enough for liquid water, but the night side, our current destination, is a realm of perpetual Arctic conditions. Here, we find something that challenges every assumption about frozen worlds: ice formations that defy the laws of physics as we understand them. The extreme cold, combined with the planet's unique atmospheric composition, creates ice structures that seem to grow like living things. Spires of frozen nitrogen reach toward the alien stars, shaped by winds that have blown for millions of years without interruption. Walking across the night side of Proxima Centauri b would be like exploring an alien ice sculpture gallery. Formations of frozen atmosphere create bridges, arches, and spirals that stretch for kilometers. Some of these ice formations are so delicate, they seem to float in the thin air, held together by nothing more than the planet's low gravity and the intricate balance of sublimation and condensation. But perhaps the most remarkable feature of these frozen worlds is what happens at their terminator lines, the boundaries between day and night. Here, we witness some of the most dynamic weather in the known universe. On TRAPPIST-1e, massive storms of frozen gases sweep back and forth across this boundary, carrying ice particles from the night side to the day side and back again. These storms, visible from space as swirling white hurricanes, constantly reshape the planet's surface, creating new ice formations while destroying others. These frozen worlds remind us that ice isn't just water in its solid state. It's a medium for creating some of the most beautiful and complex structures in the universe. They show us that even in the coldest, most seemingly hostile environments, the fundamental forces of nature continue to create art on a planetary scale. And deep beneath their frozen surfaces, in hidden oceans warmed by the fires of planetary cores, they might harbor the greatest discovery of all: alien life, evolved in isolation, waiting for us to find it in the cosmic deep. The worlds of perpetual storms. Hold on to your seats, fellow space travelers, because our next destination will test the limits of what we consider survivable weather. We're approaching the storm worlds, planets where the very atmosphere is in a constant state of violent upheaval, creating weather systems that make Earth's most powerful hurricanes look like gentle summer breezes. Our first stop, HAT P7b, a gas giant where the winds never stop and the storms never end. As we enter this planet's atmosphere, we're immediately struck by the sheer scale of the meteorological chaos surrounding us. This isn't weather, this is atmospheric warfare on a planetary scale. The winds here blow at over 30 miles per hour, fast enough to circle the entire planet in just 6 hours. But these aren't ordinary winds carrying water vapor and dust. These are streams of vaporized metals, titanium, vanadium, and iron, heated to over 40 degrees Fahrenheit and flung around the planet at hypersonic speeds. Imagine flying through HAT P7b's atmosphere. Around you, metallic clouds swirl in formations the size of continents. Lightning bolts, made not of ordinary electricity, but of plasma, heated to temperatures rivaling the surface of stars, arc between cloud formations that stretch from pole to pole. The lightning on this world doesn't just illuminate the sky, it transforms it. Each bolt is powerful enough to temporarily ionize sections of the atmosphere, creating aurora-like displays that paint the alien heavens in colors that don't exist in Earth's spectrum. But the true spectacle of HAT P7b lies in its weather patterns. Unlike Earth, where storms eventually dissipate, the storms here are powered by the planet's proximity to its star and its rapid rotation, meaning they can rage for centuries without weakening. We witness super hurricane storm systems larger than Jupiter's Great Red Spot that have been spinning for thousands of years. These atmospheric monsters create wind patterns so complex that they form their own ecosystems of smaller storms, each one feeding off the energy of the larger system. Our journey through the storm worlds continues as we visit GJ 1214b, a world where the very concept of weather takes on new meaning. Here, the atmosphere is so dense that it creates pressure conditions unlike anything in our solar system. The storms on GJ 1214b don't just move through the atmosphere, they reshape it. High-pressure systems create regions where the air becomes so dense it's almost liquid, while low-pressure zones create near-vacuum conditions that stretch for hundreds of miles. Flying through this world's atmosphere would be like navigating through an ocean of gas where the water constantly changes its density. One moment, you're moving through air thick as soup. The next, you're in a region so thin that space itself seems to beckon just overhead. But perhaps the most remarkable feature of GJ 1214b's storms is their electrical activity. The dense atmosphere creates conditions perfect for generating static electricity on a scale unknown on Earth. Lightning bolts here can stretch for thousands of miles, creating electrical discharges that temporarily turn sections of the atmosphere into plasma. These plasma storms create their own light, making the planet glow like a cosmic lantern that can be seen from light years away. From space, GJ 1214b appears as a world in constant electrical flux, with lightning networks that pulse and flow across its surface like the nervous system of some cosmic organism. The most incredible sight on these storm worlds might be their polar regions, where the atmospheric dynamics create phenomena that exist nowhere else in the known universe. On HAT P7b, the convergence of global wind patterns at the poles creates permanent storm systems that drill down through the atmosphere like cosmic tornadoes. These polar storms, fed by the constant flow of superheated metallic gases, create vortexes that extend from the upper atmosphere all the way down to the planet's core. Standing at a safe distance from one of these formations, if such a thing were possible, you would witness a tunnel of swirling plasma and metallic vapor that reaches from the surface to space itself. These storm worlds show us the awesome power of atmospheric dynamics unleashed on a cosmic scale. They remind us that weather isn't just a local phenomenon. It's one of the fundamental forces that shapes worlds and creates some of the most spectacular displays in the universe. In these perpetual tempests, we see nature as the ultimate artist, using wind and lightning, pressure and plasma to create masterpieces of motion. The impossible world. As our cosmic voyage nears its end, we arrive at destinations that challenge the very foundations of planetary science. These are the impossible worlds planets that, according to everything we thought we knew about how solar systems form, simply shouldn't exist. Welcome to TOI 849b, a planet that has left astronomers scratching their heads and rewriting textbooks. What we're looking at here defies explanation. A world with the mass of Neptune, but compressed into a space barely larger than Earth. It's as if someone took a gas giant and stripped away its entire atmosphere, leaving behind only its dense metallic core. Standing on the surface of TOI 849b would be like standing on a world made of pure metal. The gravity here is so intense that it would crush any visitor from Earth, yet somehow this world has maintained its structure despite orbiting incredibly close to its star. So close that it completes a full orbit in just 18 hours. The surface of this impossible world glows red-hot from stellar radiation, yet beneath that molten exterior lies one of the densest concentrations of heavy metals in the known universe. We're talking about a planet-sized ball of iron, nickel, and exotic elements forged in the hearts of ancient stars and somehow concentrated into this one impossible location. Our journey continues to an even more baffling destination, LTT 9779, a planet that exists in what astronomers call the Neptune Desert, a region around stars where Neptune-sized planets are never supposed to survive. This world receives 170 times more energy from its star than Earth receives from the Sun. By all rights, its atmosphere should have been stripped away billions of years ago, leaving behind a barren rock. Instead, LTT 9779b has somehow retained a puffy, inflated atmosphere that makes it one of the least dense planets ever discovered. Flying through the upper atmosphere of LTT 9779b is like moving through cosmic cotton candy. The air here is so thin and inflated by stellar radiation that the planet's density is less than that of water. It's a world that seems to float in space, held together by forces we don't fully understand. Yet this impossible survivor harbors another secret. Its atmosphere is constantly being replenished. Somehow, this world has found a way to manufacture new atmospheric gases as fast as its star strips them away, creating a dynamic equilibrium that allows it to exist in a place where no planet should survive. But perhaps the most impossible world of all is one we discovered orbiting a pulsar, the remnant of a massive star that exploded in a supernova. PSR Bone 1257 plus 12b shouldn't exist at all. Nothing should be able to survive the death of its parent star. Yet here is a world that not only survived, but thrived in the aftermath of cosmic apocalypse. Standing on PSR Bone 1257 plus 12b would be like standing in the eye of a cosmic storm. Above you, instead of a normal star, pulses a neutron star, a city-sized object containing more mass than our sun, spinning 161 times per second, and emitting beams of radiation that sweep across space like a cosmic lighthouse. The sky here would be painted with aurora displays unlike anything in the universe, as charged particles from the pulsar interact with whatever remains of this world's magnetic field. These aren't gentle aurora like we see on Earth. These are violent displays of energy that turn the entire sky into a canvas of impossible colors. Yet somehow, this impossible world continues to orbit its dead star in perfect precision, a testament to the universe's ability to create order from chaos, beauty from destruction. These impossible worlds remind us that the universe is far more creative and resilient than we ever imagined. They show us that planetary formation and survival can take paths we never considered, creating worlds in places we thought were impossible, and finding ways to exist under conditions that should be lethal. Each of these impossible worlds teaches us something new about the fundamental forces that shape the cosmos. They're laboratories where physics is pushed to its limits, where the laws of nature create outcomes that seem to defy logic, yet somehow work perfectly in the grand scheme of the universe. As we prepare for the final leg of our journey, these impossible worlds serve as a reminder that in the vast expanse of space, impossibility is just another word for not yet understood, the return home. And so, fellow travelers, our voyage through the alien worlds comes to an end. As we turn our cosmic ship homeward, accelerating back through the light years toward our pale blue dot, let's take a moment to reflect on the incredible sights we've witnessed together. We've walked on worlds where it rains molten glass and snows diamonds. We've explored oceans deeper than anything on Earth, hidden beneath ice sheets on frozen planets orbiting alien suns. We've witnessed storms that rage for centuries and lightning that turns entire atmospheres into plasma. We've discovered that the universe is far stranger, far more beautiful, and far more creative than we ever dared imagine. Each alien world we visited told us something new about the infinite ways that matter and energy can combine to create wonders beyond our wildest dreams. But perhaps the most important thing we've learned is this: in all the cosmos, with all its alien worlds and impossible planets, there's still something special about that pale blue dot we call home. Earth, with its gentle rains and breathable air, its protective magnetic field and stable climate, remains a rare jewel in the cosmic ocean. Yet our journey has also shown us that we're not alone in the universe, not in the way we once thought. While we may not have found alien life on this voyage, we've seen that the universe is full of worlds where life might flourish, where the conditions for biology might exist in forms we've never imagined. As we dock at our home planet, as Earth grows large in our view screen once again, we carry with us the knowledge that somewhere out there, in the vast darkness between the stars, alien worlds spin in the light of distant suns, each one a unique experiment in the art of planetary formation. The universe is vast, it's strange, it's beautiful, and it's full of worlds waiting to tell us their stories. Our voyage to the alien worlds ends here, but the real journey, humanity's quest to understand our place in the cosmos, has only just begun. Let's say you're floating in the deepest part of space, surrounded by absolutely nothing. No stars, no planets, no light, just emptiness, or so you think. But suddenly, without warning, the fabric of space itself starts to shake, not vibrate, shake, like a massive earthquake, except there's no ground. The invisible skeleton holding the entire universe together is cracking apart, sending shockwaves that travel faster than light itself across billions of miles. This isn't some Hollywood disaster movie. This is real. This is happening right now, somewhere in our universe, and we call it a dark matter quake. Hey everyone, what you just imagined is one of the most violent, mind-bending events in the cosmos. I'd like you to take a brief moment to join a community that values curiosity over conformity. Hit that subscribe button and let's explore the extraordinary together so you'll never miss a video. Today, we're diving deep into the most extreme, reality-breaking phenomena ever discovered in space. We're talking about explosions that make our sun look like a birthday candle, black holes so massive they could swallow our entire solar system for breakfast. And yes, those dark matter quakes that literally break the universe's backbone. Buckle up. The universe is about to get a whole lot weirder than you thought. The invisible universe. Okay, let's start with something that's going to blow your mind. Ready? Everything you can see in the night sky, every star, every galaxy, every beautiful nebula photo from the Hubble telescope, all of that represents less than 15% of what's actually out there. Imagine you're at a concert, but you can only hear 15% of the music. The other 85%? Completely silent to your ears, but it's there. And it's what's actually driving the entire symphony. That's our universe. The majority of it is made of something called dark matter, and it's completely invisible. Can't see it, can't touch it, can't Instagram it. But here's the thing. This invisible stuff is literally holding everything together. Think of dark matter like the universe's skeleton. Just like you can't see the bones inside your body, but they're what keeps you from being a puddle on the floor. Dark matter creates this massive cosmic framework that galaxies hang on to like Christmas ornaments on a tree. But here's where it gets insane. This skeleton isn't solid. It's more like a giant spider web made of invisible rivers and streams stretching across the entire universe. Scientists call it the cosmic web, and it's probably the most beautiful thing you'll never see. Our Milky Way? It's just sitting in one tiny corner of this web, surrounded by dark matter that weighs 5 times more than all our stars combined. And for the longest time, we thought this web was pretty stable. We were wrong, dead wrong. In 2019, scientists noticed something weird. Stars in our galaxy were moving like they'd been hit by a massive invisible truck. Something enormous had crashed through our cosmic neighborhood, leaving behind what looked like stellar tire tracks. They called it the Gaia sausage, which sounds way less terrifying than it actually is, because what it meant was that the dark matter web around us isn't nearly as stable as we thought, and that was just the beginning of the nightmare. When the universe breaks. Meet Dr. Elena Rodriguez. She's the kind of scientist who stares at radio telescope data all day and somehow finds it exciting. Lucky for us, because what she discovered is absolutely terrifying. She was looking at signals from some of the most powerful radio telescopes on Earth when she saw something that should have been impossible. Multiple galaxy clusters. We're talking structures containing thousands of galaxies each. We're all freaking out at exactly the same time. Here's the problem. These clusters were so far apart that light hadn't even had time to travel between them. It's like having earthquakes simultaneously hit Japan and California. Except Japan and California are separated by billions of years of travel time. At first, I thought our equipment was broken, Dr. Quote. Rodriguez said. But the more we looked, the more we realized we weren't seeing broken equipment. We were seeing a broken universe. What she had stumbled onto were the first confirmed dark matter quakes. Remember that cosmic web I mentioned? Well, imagine if all the cables on the Golden Gate Bridge were under massive tension, and then one of them just snapped. The other cables would start failing in a chain reaction, right? Now scale that up to cosmic proportions, where the cables are made of invisible matter and stretch across distances that would take light billions of years to cross. The biggest dark matter quake ever recorded happened in something called the Boete supervoid. Don't let the fancy name fool you. This thing is basically a cosmic dead zone that's 330 million light-years across. To put that in perspective, if our galaxy was the size of a coin, this void would be bigger than Texas. And inside this void, something unimaginable happened. A dark matter structure just collapsed. The energy release, more powerful than a billion supernovas exploding at once. But here's the really weird part. Unlike a supernova that lights up the sky, dark matter quakes release their energy as pure gravitational waves, invisible ripples in space itself that we're only just learning to detect. Remember those gravitational wave detectors that won the Nobel Prize for finding black hole collisions? Yeah, they started picking up these weird signals in 2020. At first, scientists thought it was just noise. Turns out, it was the universe screaming. But if you think dark matter quakes are extreme, wait until you hear about the most violent explosions in the cosmos. Cosmic explosions that make nukes look cute. December 27th, 2004. Christmas was over. Everyone's dealing with post-holiday blues. And then the universe decided to remind us just how small and fragile we really are. An explosion 50 light-years away, that's halfway across our galaxy, was so violent that it temporarily blinded space telescopes and actually messed with Earth's atmosphere. If this explosion had happened just 10 light-years from us, you wouldn't be watching this video, because complex life on Earth would be extinct. This was a gamma-ray burst, and they are absolutely the most ridiculously overpowered events in the known universe. Here's how insane these things are. A single gamma-ray burst can release more energy in 10 seconds than our sun will produce in its entire 10 billion-year lifetime. Let me say that again. 10 seconds versus 10 billion years. But that explosion in 2004, that was nothing compared to what we detected in 2022. GRB 221,009A was an explosion so bright that it happened 2.4 billion light-years away and was still visible to the naked eye from Earth. For a brief moment, this explosion outshone every single star in our night sky except the sun. Think about that. An explosion that happened when Earth was just forming single-celled life was so powerful that it could still light up our sky like a new star. These explosions happen when the most massive stars in the universe finally run out of fuel and collapse. But they don't just collapse. They collapse and then fire jets of material at 99.9% the speed of light. We're talking about cosmic blowtorches that can sterilize entire solar systems. Dr. Michael Chen studies these things for a living, and even he sounds scared when he talks about them. A single gamma-ray burst releases more energy than all the stars in the observable universe will produce over the next trillion years. But as absolutely insane as gamma-ray bursts are, they're still just the death throes of individual stars. What happens when entire black holes go to war with each other is on a completely different level. When black holes fight, in the center of almost every galaxy, there's a monster. A supermassive black hole that's millions or billions of times heavier than our sun, just sitting there like a cosmic vacuum cleaner, occasionally snacking on nearby stars. Most of the time, these things are pretty quiet. But when galaxies crash into each other, and yes, galaxies crash into each other all the time, their central black holes get forced into the ultimate deathmatch. Picture two black holes, each weighing as much as 1 billion suns, spiraling toward each other for millions of years. They're moving so fast and generating so much gravitational energy that they literally warp space and time around them. When they finally collide, the explosion is so violent that it creates gravitational waves powerful enough to kick the resulting black hole clean out of its galaxy. These rogue black holes have been spotted racing through space at thousands of miles per second, carrying the mass of 100 million suns with them. Imagine a black hole the size of our solar system, just flying through space like a cosmic cannonball. But even scarier than black hole collisions are black holes that are actively feeding. Meet TON 618, the brightest object in the known universe. This thing is powered by a black hole that weighs 66 billion times more than our sun. It's so bright it outshines 140 trillion stars, and it's hungry enough to eat our entire solar system every few days. When matter falls into one of these monsters, it heats up to billions of degrees and gets shot out in jets that stretch for hundreds of thousands of light years. These jets move at nearly the speed of light and can punch through entire galaxy clusters like cosmic drill bits. The most extreme feeding frenzy ever recorded happened in a galaxy with an unpronounceable name that I'm not even going to try to say. The central black hole basically had cosmic indigestion and started ejecting material so violently that it cleared out everything within thousands of light years. The energy release was like our sun, exploding every single second for 1,000,000 years straight. But here's the thing about all these cosmic disasters. They all involve normal matter and energy. Dark matter quakes are something completely different. They're failures in the underlying structure of reality itself. The discovery that changed everything. Sometimes the biggest discoveries happen by accident, and sometimes they happen because you let a computer program loose on data that would take humans centuries to analyze. That's exactly what happened to Dr. Yuki Tanaka in Tokyo. She was using artificial intelligence to analyze the positions and shapes of hundreds of millions of galaxies, looking for tiny distortions caused by gravity bending light. It's incredibly detailed work that basically maps the invisible matter in the universe. But the AI kept finding things that didn't make sense. The machine kept flagging regions where gravity was acting weird. Dr. Tanaka explained. At first, we thought it was finding errors in our models. Then we realized it was finding errors in reality. What the AI had discovered were scars. Gravitational scars left behind by dark matter quakes, or NTED. Regions where the cosmic web had catastrophically failed, leaving behind twisted space that was still affecting galaxies hundreds of millions of years later. The first confirmed dark matter quake, DMQ-1, had happened 50 million years ago in the constellation Perseus, but its effects were still there, still warping space, still influencing how galaxies moved through that region. But here's where dark matter quakes get truly bizarre. Unlike earthquakes on our planet, which spread out through seismic waves at a few miles per second, dark matter quakes can trigger simultaneous failures across vast distances through something called quantum entanglement. It's like having a house of cards, where pulling out one card can cause cards on the other side of the room to fall at exactly the same moment. Dr. James Morrison from Oxford University tries to explain it. When a large dark matter structure collapses, it creates a phase transition that propagates instantly through quantum connections in the field. We're talking about faster than light effects, not for information, but for structural changes. In other words, dark matter quakes don't just break the cosmic web locally. They can trigger cascading failures across distances so vast that light hasn't had time to travel between them since the universe began. And then came the discovery that made everyone realize we might be living in a fundamentally unstable universe. The Great Cascade. March 15th, 2023. Mark that date, because it's the day we discovered that our entire cosmic neighborhood is basically held together with cosmic duct tape. Gravitational wave detectors around the world started going absolutely crazy. Not just one or two signals, hundreds of them, all happening simultaneously across our local group of galaxy clusters. The Laniakea supercluster, Our cosmic address that includes over 100 zero galaxies, including our own Milky Way, was experiencing what can only be described as a dark matter earthquake swarm. Dr. Lisa Chen led the international team that monitored the event. Our detectors were triggering constantly. We had galaxy surveys showing unexplained movements across thousands of objects. For a moment, we genuinely wondered if we were witnessing the beginning of a universe-wide collapse. The Great Cascade started with one massive dark matter quake in the Virgo cluster, 65 million light-years away. Within hours, it had triggered secondary quakes in the Coma cluster, the Perseus cluster, and dozens of smaller galaxy groups. It was like watching dominoes fall, except each domino was a structure containing billions of stars, and they were falling faster than light could travel between them. For 3 weeks, our cosmic neighborhood was in chaos. Over 200 individual dark matter quakes were detected, ranging from small events affecting single galaxy groups to massive failures that reshaped the cosmic web across hundreds of millions of light-years. The total energy release? If we could somehow convert all that gravitational energy into visible light, the Great Cascade would have briefly outshone every star in the observable universe combined. But here's what really kept scientists awake at night. Computer simulations suggested that our supercluster had been building up stress for billions of years. The Great Cascade wasn't a random disaster. It was a pressure release valve, nature's way of preventing an even bigger catastrophe. As Dr. Rodriguez put it, we're living inside a structure that's fundamentally unstable. It's like living in a house built on an active volcano, except the volcano is made of invisible matter and could erupt across the entire observable universe. The question that haunts cosmologists is simple. What happens when the next cascade isn't a controlled release? But before we get to that nightmare scenario, let's talk about the smaller scale cosmic disasters that happen closer to home. When stars have nervous breakdowns, you think dark matter quakes are extreme? Let me tell you about magnetars, the universe's answer to the question, what if we made something that could kill you just by existing near it? A magnetar is what happens when a massive star collapses into a neutron star, but then cranks up the magnetic field to absolutely ridiculous levels. We're talking about magnetic fields 1 trillion times stronger than Earth's. How strong is that? Strong enough that if a magnetar was located where the moon is, it would erase every credit card, hard drive, and cell phone on Earth. If it was 600 miles away, it would literally tear apart your atoms. These things are so dense that a teaspoon of magnetar material would weigh as much as Mount Everest. And their crust, yeah, they have crusts made of crystallized neutrons, is under so much stress that when it shifts by just a few millimeters, it releases more energy than our entire civilization has ever produced. In 1998, a magnetar called SGR 1900-14 had what can only be described as a stellar temper tantrum. The starquake released energy equivalent to 1 million hydrogen bombs exploding every second for an entire year. But magnetars aren't the only stars having cosmic breakdowns. There are Wolf-Rayet stars out there that are so unstable they're literally blowing themselves apart. These stellar monsters lose mass equivalent to our entire Earth every single year through stellar winds moving at thousands of miles per second. And when they finally explode, we call those hypernovae, and they make regular supernovas look like firecrackers. Hypernovae are so violent they can carve tunnels through space itself, creating jets of material that remain active for weeks and can trigger mass extinction events on planets hundreds of light years away. But even these stellar disasters follow the normal rules of physics. The really scary stuff happens when the fundamental building blocks of the universe start to break down. The universe's expiration date. Here's something that will keep you up at night. The universe might have an expiration date. Everything we know about physics suggests that the Higgs field, the thing that gives particles their mass, is in what scientists call a metastable state. It's stable for now, but it could potentially collapse to a lower energy state. If that happened, it would create a bubble of completely different physics, expanding outward at the speed of light, destroying everything it touches by literally changing the rules of reality. But here's something even scarier. Dark matter might be subject to the same kind of instability. Dr. Tanaka's latest research is genuinely terrifying. The frequency of dark matter quakes has increased by 300% over the past decade. This could be natural variation, or it could mean we're approaching a critical threshold where the entire dark matter field becomes unstable. Imagine if the invisible skeleton holding the universe together just started dissolving. Not all at once, but in cascade failures that spread faster than light, turning the cosmic web into cosmic dust. Entire galaxy clusters would lose their gravitational anchor and fly apart. Stars would be flung into the void. The carefully balanced dance of cosmic structures that took 13.8 billion years to create would unravel in a matter of centuries. But before you start building a bunker, there's some good news. The same forces that create these extreme events also drive the creation of new structures. Dark matter quakes, while devastating to existing cosmic architecture, actually clear space for new galaxy formation. Recent observations showed dark matter deserts, regions cleared out by major quakes, beginning to refill with new streams of invisible matter. The cosmic web is more resilient than we thought. And who knows, maybe our growing understanding of these extreme events will lead to technologies we can't even imagine yet. If we could learn to predict or even influence dark matter quakes, we might eventually be able to engineer the large-scale structure of the universe itself. Now that would be something. So here we are, at the end of our journey through the most extreme, mind-bending, reality-breaking events in the cosmos. From stellar explosions that outshine entire galaxies to dark matter quakes that literally tear apart the fabric of space itself. What have we learned? Well, for starters, we live in a universe that's way more violent and unstable than most people realize. The ground beneath our feet, metaphorically speaking, is made of invisible matter that can shift without warning across billions of light years. But here's the amazing part. Despite all this cosmic chaos, here we are. Stable planets orbiting stable stars in a relatively stable galaxy, in a universe that's trying its best to tear itself apart. We are literally islands of calm in an ocean of cosmic violence. And that makes our existence not just unlikely, but almost miraculous. Every time we discover a new type of extreme event, whether it's a gamma-ray burst that can sterilize entire star systems, or a dark matter quake that reshapes the cosmic web, we're not just learning about distant disasters. We're learning about the fundamental forces that govern our cosmic home. And we're just getting started. Right now, as you're watching this video, telescopes around the world are detecting new signals, new patterns, new types of extreme events that we've never seen before. The universe is constantly writing new chapters in the story of cosmic violence, and we're finally learning to read them. So the next time you look up at the night sky, remember this: those peaceful-looking stars are sitting on top of an invisible web of dark matter that occasionally has catastrophic failures. That beautiful Milky Way stretching across the sky is surrounded by a halo of invisible matter that outweighs all our visible stars by 5 to 1. You're not just looking at a few thousand nearby stars. You're looking at the visible edge of a vast, dynamic structure that extends across the entire observable universe. A structure that's constantly evolving, occasionally breaking apart, and always rebuilding itself in new and unexpected ways. We live in the most extreme universe imaginable, and somehow, against all odds, we're here to witness it. The cosmos is stranger, more violent, and more beautiful than we ever dared to imagine. And tomorrow our instruments will detect something new, something that will once again expand our understanding of just how extreme reality can get. Until next time, keep looking up,
The universe is full of surprises. And trust me, you don't want to miss what happens next.